Good morning. This is Kasturi Day. Today again I've come to discuss the heat transfer chapter according to ICSE syllabus class 8. Okay. So in my last video I started with the discussion that introduction. I started with the introduction and then the effects of heat, and now today I'm going to start with the effects of heat, continuation of that chapter, of that topic. Okay. So effects of it is change in size of the body. When a body is heated, it expands on, and on cooling it contracts. Okay. So it's in my last video I told you that effects of heat, the heat effects, it is affected by the change in temperature of the body, in the state, change in the state of the body, and change in the size of the body. Okay. So uh, change in temperature is dependent on two factors, that is quantity of heat and materials of the body, and change in the state of the body dependent on the that matter in that is matter exists in three different states, that is solid, liquid, and gas. And in solid is heated, it changes into its liquid at a fixed temperature, that's melting. And then liquid, when it is cooled, it changes, the liquid changes into solid at a fixed temperature, that is freezing. Then we come to this liquid. When it is heated, it changes into gas at a fixed temperature, that's vaporization or boiling. And when vapor condenses, it changes into liquid, then it is condensation. This all happens at a fixed temperature. Okay. Then when a solid is directly changing into vapor, it is sublimation. And when vapor directly changes into solid without melting, then it is without becoming liquid, that is solidification or deposition. Again, the change of state of the state from liquid to gas at all temperature is evaporation. Okay. Then this evaporation, this during evaporation, heat is either absorbed or rejected. Okay. The change of state, when there is a heat is absorbed or rejected, that is latent heat or hidden heat. Okay. And it is not manifested by any change in temperature. There is no change in temperature during this process. Okay. And when it is this latent heat, when expressed in unit mass, that is known as specific latent heat. Okay. Now the latent heat does not occurred in the but it does not require any change in temperature, but changes the force of attraction between the molecules of a substance. Okay. So temperature remains constant, and the absorbed or rejected heat has no effect on the speed of the average kinetic energy of the molecule. So during interconversion, the latent heat increases or decreases only on the average potential energy, not on the average kinetic energy. Average kinetic energy remains unchanged, whereas average potential energy only changes during this interconversion of the states. Okay. Now next is it depends that another effect of heat is change in the size of the body. So when a body is heated, it expands, and on cooling it contracts. So the change in the size of the body due to heat, which is known as thermal expansion. Okay. This change in size in the body, okay, when the body is heated, there is a change in the size of the body, and that is known as thermal expansion. Okay. So this thermal expansion is of three types. Okay. So first is linear expansion, second is cubical expansion, and third is superficial expansion. Okay. So linear expansion is when there is an increase in the length of a solid due to heat. When the length increases or decreases, okay, due to heat, when the length increases, that is known as linear expansion. Okay. Then superficial expansion is when there is a change in the increase in area, okay, due to absorption of heat. When the solid absorbs heat and their area changes, area of the solid changes, increases, then that is known as superficial expansion. And cubical expansion is when there is an increase in volume of a solid, liquid, or a gas. Cubical expansion, when there is a change in volume, that is increase in volume in the solid, liquid, or gas due to absorption of heat. Okay. Now we come to effects of temperature on the molecular motion. It is known that the molecules of each substances possess kinetic energy by the virtue of its continuous motion. We know that molecules always they are in motion. So due to their motion, due to their virtue of the motion, they possess kinetic energy. When this motion becomes less rapid, okay, they become slowly they are moving, its temperature decreases, or if the temperature decreases, the molecular speed decreases, vice versa. Okay, at high temperature the molecules are very much agitated, they move very fast, and so their kinetic energy also increases. Okay, the temperature, when the temperature becomes zero, the molecular motion ceases. When the temperature actually becomes zero, then that molecular motion ceases. It does not move, the molecules do not move. Okay, the temperature at which the molecular motion ceases completely, when it stops complete motion, okay, that is known as absolute zero on the Kelvin scale. Okay, temperature lower than this temperature, that is absolute zero, below that temperature is not possible. Okay, is not possible. Now change of liquid into vapor state. Okay, so it happens in two ways. Okay, what are those? First is by evaporation at all temperatures, okay, and then is by boiling at a fixed temperature. See, evaporation takes place at all temperatures and boiling takes place only at a fixed temperature, that is known as boiling point. Okay, so evaporation is the phenomena of change of liquid, of a change of a liquid into its vapor at any temperature below its boiling point. So the temperature of the liquid which changes the liquid into vapor during evaporation does not reach the boiling point. Okay, below that the liquid changes into vapor without any external source of heat. It does not require an external source of heat. Okay, it takes the heat from the surroundings. It is the surface phenomena, and it increases if a given liquid absorb heat energy from the surroundings. Okay, at room temperature also the liquid starts evaporating, liquid evaporates. Okay, and this phenomena, it's a surface phenomena, that is from the surface only the liquid evaporates. Okay, and during this evaporation process speeds up when it absorbs much more heat energy from the surroundings. When it absorbs heat energy from the surroundings, this evaporation process speeds up. Then explanation of evaporation on the basis of molecular motion. What happens? See, in liquids the intermolecular forces of attraction is weak. We know that in weaker than the gas, not so strong than the gases. Okay, this intermolecular force of attraction is not so strong, so to keep them in the fixed position. Okay, like the solids, their intermolecular force of attraction is very strong, so that the molecules remain in a fixed position. But in liquids it is not so strong, so that it does not remain in the fixed position. So in liquid molecules they can move throughout the liquid. Okay, the molecules of a liquid on an average has a larger speed than the molecules of a solid. When a moving molecule reaches the surface of the liquid, it is pulled inside by the cohesive force of the surrounding molecules of the liquid, as there are no molecules on the other side of the surface. See, when these molecules are in motion, no, the liquid molecules are in motion, so they're moving faster than the solid. So by this way, when in this process, when they reach the surface of the solid, so there are no other molecules outside the surface of the solid of the liquid. That means the liquid molecules are not there outside the surface of the liquid. So what happens? The liquid molecules, the surface of the liquid molecules, that with those molecules, the surface molecules, they are pulled inside by the cohesive force of the surrounding molecules of the liquid towards inside. Okay, so the molecules are not allowed to leave the surface, and a liquid has a definite volume. Therefore the liquid has a definite volume. Okay, but in the gas what happens? The molecules are very much farther apart. Okay, the molecules in the gas, their intermolecular force of attraction is very weak. Okay, I mean they are the attraction is least, you can say. Okay, very weak, so they move very much further apart. Okay, the intermolecular force of attraction is very small or negligible, you can say, and the molecules are free to move about the entire available space, so they do not have any fixed volume or neither any shape. Okay, then what happens, this in the liquid moving molecules collide with each other, and some molecules, these molecules in the liquid, they are moving, no, so in this process they collide with each other, and some molecules gain energy and some molecules lose energy in this collision. So when these molecules which gain energy, they reach to the surface of the liquid, they, what do? They gain sufficient kinetic energy again, and they act against the cohesive force, which are cohesive force which is pulling them inside. So they gain sufficient kinetic energy so to act against this cohesive force, and they escape out from the surface into the space. That is, they change into vapor. And those molecules which lose energy during this collision, they remain inside the liquid. Okay, that the rate of evaporation depends on the temperature of the liquid, wind or the blowing air, surface area, and presence of humidity. Now, temperature of the liquid is when the rate of the evaporation increases, if the temperature of the liquid increases, because the energy of the molecules increases with the increase in temperature. Okay, so more and more molecules come to the surface of the liquid, and the rate of evaporation increases with the increase in temperature. That is, when the temperature increases, they gain more kinetic energy, and they start leaving, more of the surface molecules start leaving the surface of the liquid. Now, when there is a wind or blowing air, when the weather is windy, okay, when the climate is windy, then when air is blowing over the surface of the liquid, the rate of evaporation increases, because the blowing air takes away the surface molecules of the liquid with it. To take their place, the other molecules, they also move to the surface of the liquid and get exposed to the wind. Okay, now then the surface area. Okay, uh, the surface area, if the exposed area of the liquid is increased, okay, if we keep a cup of tea in a tea in a cup and a saucer, so the exposed area of the saucer is more than the cup. So in this way, when the exposed area is increased, the rate of evaporation also increases, because on the increasing the surface area, the number of molecules which are exposed to the surface, that increases, and they start escaping, more of it escapes out. Okay, and then presence of humidity. If there is humidity in the air, the rate of evaporation becomes slow, and because of this, what happens, that is because water vapor is present in the air, and that does not allow the molecules of the liquid to find space to escape. Okay, so I'll stop here. I'll continue with the rest of the question answer, this chapter in my next video. Please go through this. If you have any doubt, please do write in the comment box. Okay, and hope you are liking the videos. Press the like button and do subscribe to get the notification of my next video. And please wait for my this website to be launched. I'll be launching this website very soon, so wait for that. It will contain more information on your subjects and also different other subjects, and some more interesting things there are I'll be launching, so please wait for that. Okay, thank you for watching.